So we were working on removable discontinuities, and now what we're going to do is we're going to look at another form of discontinuity, which is called a vertical asymptote. Now, vertical asymptotes is the one asymptote you can never ever cross. The reason why you can't cross a vertical asymptote is simply because then you would be dividing by zero, and we're never allowed to have a zero in the bottom part of a fraction. In this case, even though this is a rational function, it is still a fraction and the rules still apply. So we're going to do vertical asymptote. All right, now anytime you have a rational function and we're looking to graph it, you might as well just factor it right off the bat if it's factorable, because that will make your life a whole lot easier. So I'm going to factor this right off the bat. I'm going to say f of x equals, let's see, the top factors to x minus 5, x plus 1, and the bottom is going to factor to x minus 5, x, let's actually write a 5 instead of number, x minus 5 and x plus 4. Okay, so now I'm fully factored, and I do notice, hey, I have an x minus 5 and an x minus 5, so I have a hole, I have a removable discontinuity. So we already know that x cannot equal, well, if I just set this equal, x minus 5 cannot equal 0. We know x cannot equal 5. And I'm going to reduce this. Boom, boom. I have f of x equals x plus 1 over x plus 4. Now, for my hole, all I have to do is take this and plug it in there. So I know my x value is going to be 5, so I'm going to do 5 plus 1 over 5 plus 4, which gives me 6 over 9, which is 2/3. Voila. So there's my hole. That wasn't hard to find since we had it, since it was there, and we're building up to actually sketching these. All right. So now what I have to do is, and I need to look and see what other number can't I be? What other number can this not be? Well, what I'm going to do is I'm going to take whatever's left after I reduced it, taking any removable discontinuities out, and I want to set that not equal to 0. So I'm going to say x plus 4 cannot equal 0. And I'm going to solve. I'm going to say x cannot equal negative 4. That's a vertical asymptote. If you can't take it out, if you do not have a hole or a removable discontinuity, whatever makes your denominator equal to 0, that's going to be your vertical asymptote. Now it's a line, so it's going to be an equation of a line x equals. So my vertical asymptote is going to be x equals negative 4. Now what we want to do is try to figure out what is the graph doing around negative 4. Just like we wanted to know what was the graph doing around 5. Here's where I'm going to use my limit notation. And we're going to use a table on this one. There is no trick like I showed you last time where you can just plug it in to find the values. We have to do a table on this. Eventually you'll kind of get a feel for what's actually going on. So we're going to do the limit as x approaches negative 4 from the left of my function. I'm going to use my reduced function. So I'm going to do an x and a y. I'm going to do that table. And then I'm going to say the limit as x is approaching negative 4 from the right of my function. I'm going to use a table. Tables will never fail you when you're doing a limit. Remember that when you're taking calculus. Tables will never fail you when you're doing limits. All right, so we need a number to the left of negative 4, so that's going to be negative 4.1, negative 4.01, and negative 4.001. I'm going to put these numbers in. I get 31, 301, 3001, and these are all rounded, so I have a decimal right there to tell you that I rounded them. And all I did was take those and put them back into the reduced, just like how we did the first time to find the whole, the y value of the whole. Just take these, plug them in the reduced point, and you get these values. Now, if I look at this and say, the closer I'm getting to 4, the really bigger the number my graph is getting. So this is actually going to go to infinity. Because whenever we deal with anything with vertical asymptotes, my answer is either going to be infinity or negative infinity. Well, in this case, it's going really big. It's getting really big, so it's got to go to infinity. Now, don't ever assume that they're always going opposite directions, because they can be going in the same directions. So don't assume it. Always do your tables. Now we're going to come from the right, which is going to be negative 3.9, negative 3.99, negative 3.999. So I'm just starting a little further away and then getting closer on each iteration. I always like to do 3 so I can identify the pattern. Other teachers will have you do less than 3 or more than 3. I just like doing 3 because it helps you identify the pattern. All right. When I do this, I get negative 29 rounded, negative 209 rounded, and negative 2,909 rounded. So that's pretty clear to me. It's going down really fast. Closer I'm getting to negative 4. So this is going to be negative infinity. So this is, whenever you find your vertical asymptotes, find how it's behaving around the vertical asymptotes. Because when we get to sketching the graph, this is going to help you tremendously. Instead of just kind of guessing at it. So this is it. This is vertical asymptotes. Once you take out you want to factor first, take out any removable discontinuity. Whatever is left, take your denominator, set it not equal to 0, so we know x cannot equal 4. Now my vertical asymptote is an equation of a line, so it's going to be x equals 4, because it's a line, it's a vertical line. And then we're going to just look and see how is the graph behaving around negative 4 from the left. This minus means from the left, and how it's behaving as it's coming from the right. This plus means coming from the right around negative 4. The best way to do that is with. So we're building up to sketching these graphs. These graphs are very unique and really kind of cool looking in my opinion. So yeah, let's keep moving. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.